This is the z-score table on page 167 and 168 of the activity packet, and I wanted to go through how to use it to find the z-score. So suppose you know the z-score, which you can use the z-score formula that we'll see in a later activity to figure out. Then if your z-score was negative, the negative z-scores are on page 167. So you can see the part of the graph shaded for the z cutoff is on the left side of the 0, which is the middle of the graph. In this chart, they assume that the mean is 0 or the proportion is 0, so that's why there's a 0 in the middle. That's the simplest example. So if your z-score was, say, 2.47, you would come down the left column until you find, we'll say negative 2.47, and you'd find the negative 2.4, and then up along the top, these columns are the hundredths place. So you would come over to the 0.07 and bring that down to the negative 2.4, and then right there would be your z-score. So let's go ahead and circle it. So you could circle right here. Here's the z-score. For negative 2.47. So this would be a z-score of 0.0068. So this, if you were going to make it a percent, if you moved it 2 places, this would be less than 1%. So that would be over here on the left side of the graph because it's negative. Suppose you wanted to find the z-score that corresponded with a 30% probability or 0.30 probability. So we would 0.30 proportion. So we could come down and try to figure out where can we be closest to 0.30. So if we look, okay, got to go down more and more and more. If we look, here's 0.3015, and here's 0.2981. So the z-score is going to be somewhere in here, and actually 0.3015 is closer to 0.30, even though it's a little bit above, than 0.2981. So this will be our closest z-score to 30% or a proportion of 0.30. And so we see over here in the left column, this is negative 0.5, and then if we go up to the top, we see this is a 2 in the hundredths place. So this z-score would be negative 0.52. So let's go look at the next page, 168. So over here on page 168, now the z-score is shading above the mean or above the proportion. Remember, the mean is if we have quantitative data, the proportion is for categorical data. And right now in our packet, we're mostly looking at categorical data. So say I had a z-score of 0.77 on the positive side, that's meaning 0.77 standard deviations above the mean. We would come down to the column to 0.7 in the tenths place, and then come over to 0.07 in the hundredths place, and we could circle. There's our z-score. All of the values in this chart were figured out using calculus or a computer to numerically approximate. So basically, somebody already did the work of calculating all these z-scores and then organized them nicely in the chart for us. Suppose we were looking for where is 75% of the data, or 0.75 is the z-score, and we see here's 0.7486 and here's 0.7517. So in this case, 0.7486 would be a little bit closer to 0.75, so we can circle that as our z-score that corresponds to 75%, and that would go with a z-score of 0.67. So you can see, using this chart, you could find any standard deviation, any z-score for any standard deviation, and then find the corresponding percent or proportion. How high does the chart go? If you look, the highest value is 0.9998 because we know we can never have more than 100% of the data. And if you look back to the low side on page 167, the lowest proportion goes to 0.0003. Usually after this point, your graphing calculator rounds the z-score to 0. So you may sometimes see a z-score of 0, and that would be if it's very, very low.